Hi, this is Kevin Laumeister. I would like to present my symmetry project for FHSU MIT 812. This project is for my 8th grade students who have just completed an intro lesson to symmetry. My project description: students are going to explore different structures throughout the world. They're going to use Google Earth to explore these structures. They're going to find as many types of symmetry that they can and apply to them. That falls under ISTE E6B. This will lead to a class discussion about shapes with multiple symmetries. Students will also need to justify what they feel type of symmetry is present if something controversy as to symmetry is present, and this will cause students to have deep, meaningful relationships. A lot of times symmetry has controversy to it, and so it would cause good conversation. That's ISTE E5B. My audience for this project is 8th grade pre-algebra students who have completed an intro lesson on symmetry. This may include students who are absent because I did include a video in this project that shows a basic description of the 3 types of symmetry. So even if they missed the intro lesson, since they're working in a group and they are able to watch the video, they might be able to get caught up pretty fast to do this project. And then students also have the ability to challenge themselves. This will differentiate my instructions a little bit. If a student is really understanding symmetry, they can find multiple symmetries or symmetries that are a little harder to see in the project. The objective for this, at least one type of symmetry is identified in each structure. All types of symmetry are identified by the end of the project. Students will defend their choices when we have a discussion following the project, and the students will be able to identify symmetry anytime when assessed. All right, let's talk about the process here. I've got Google Classroom set up for my students. So here's the assignment, as you can see. This is the intro video that I made earlier in the course. It's just a short clip. So that's my intro video for the students, and then next they can click on the symmetry instructions, which is the Google Doc they'll be completing the lesson in. So the Google Doc here has the lesson, and basically it gives students the directions as to what they're to do. So this tells them that they need to get into Google Earth and click on the following links, and then once they get in there, they need to answer the following questions. What type of symmetry do you see? And what evidence justifies the symmetry? Each student will have their own copy of this Google Doc, and they'll be able to submit it at the end of the lesson. So if they click on this link for the Pentagon, it would take them to Google Earth, and as you can see, the Pentagon. This first one is just an aerial view of the Pentagon. There's 2 types of symmetry I'd expect students to say. They could say it has reflective symmetry, because if you drew a line right down the middle here, one side would reflect directly onto the other. This also has rotational symmetry. If you took this point of the Pentagon and rotated it to this point, it would look exactly the same as it did before. Going back, I would expect them to put that down here. What types of symmetry do you see and what justifies your evidence? Then they could click on the Taj Mahal link right here. That would bring them up to Google Earth, which is right here. This is a more of a ground view rather than an aerial view. Google Earth is really cool. You can click around. It's an augmented reality situation here. So as you can see, Taj Mahal is very symmetrical. If you split it right down the middle, one side would reflect right onto the other. There's actually a building over here that looks identical to the building over here as well. So students could mention something about that. There's translation symmetry here. If you took this arch right here and slid it over to the right, it looks exactly the same. And same with this arch, could slide directly to the right. So here's an example of where students would type in, I see reflective symmetry and translation symmetry in the Taj Mahal. Then they would go to the Lotus Temple, um, I don't even know how to say that, Santa Corse. And then last but not least, they get their choice to pick a document or I shouldn't say document, a structure of their own that they would like to explore. And that's what this paragraph is saying. And once again, answer the questions. So this kind of gives them that little versatility of, hey, I know of a place that would be symmetrical, and they have to do the research themselves. Once they've completed the lesson, they would turn this into Google Classroom, and then I could go through and grade them. I think I would like to try the Doctopus, which I found earlier in this course, where it's easy to just organize students on a Google sheet. If students get stuck, there is a video down here that I made about the 3 types of symmetry. So here's the video of me. Maybe. There it goes.
Hey, if you're watching this video, you probably forgot about some of the symmetry that we've learned so far in this unit. So let's quickly review those 3 types of symmetry that we've learned so far. The first type is reflective symmetry. The example I'm going to show you is the letter T, the capital letter T, that shows reflection symmetry. If you drew a line right down the middle of the capital letter T, you would notice that one side reflects onto the other. And it's just like you looking in a mirror. So think of a reflection when you think of reflective symmetry. The next type of symmetry is translation symmetry. An example of translation symmetry would be music notes. If you look at music notes, then you would see that if it's something that tends to repeat itself, it just slides over. That's the key word for translation symmetry, is sliding. So that first set of music notes has slid to the right and made an exact replica of itself, and it looks exactly the same. It's just slid a little bit. The third type of symmetry that we talked about is rotation symmetry. Rotation symmetry is where you would take a picture and rotate it, and it would look exactly the same as it did when it began. So, for example, a 5-point star. If you take the top of that 5-point star and rotate it, it would end up looking exactly the same after a certain degree of rotation. And we have not learned how to figure out how many degrees that is yet, but you will soon. So there's your 3 types of symmetry. I hope this helps.
Okay, so that's if students were either absent or stuck on symmetry. It's a short, brief lesson on what they had learned the day before on the 3 types of symmetry. So that's it for Google Classroom, and that's it for the project. Once students turn that in, I can assess it, get back to them. It kind of gives me an idea of if they really are understanding what symmetry is or not. When I'm reflecting over this this whole class and this project, I really had a lot of fun. There was a lot of exploring. Exploring Google Earth was fun. Creating the Powtoon, I think I did a little better than the first time I had attempted it in another course. I think that's going to be a good classroom tool. So I really enjoyed that. And really just exploring the different types of media that there are for this project. As you can see, I used several different types, and they were all for a purpose. This is a standard, this ISTE standard, that I usually have a hard time figuring out how I would incorporate, and I think this project does a good job of establishing a learning culture that promotes curiosity. I think students could get really curious about structures throughout the world, historical stuff, and symmetry, and critical examination of online resources that fosters digital literacy and media fluency. So I think that this had a good curiosity factor to it for students to learn. And of course, the project incorporated many multimedia sources for a reason. I think that a lot of times we get stuck just using technology because we can. So I think this one, everything had a purpose behind it. So that's about it. Thanks for watching.